All right, I believe we are in part 4, hopefully, because that's what I'm labeling this as. Review part 4, and so we are on number 16 of the final exam review. So we want to, through the next 5 problems, we want to establish identities. So the first one that we have is the cotangent of x plus 1 squared. And then I'm going to add the cotangent of x minus 1 squared. And we want that to equal 2 cosecant squared of x. 2 cosecant squared of x. So I'm going to go ahead and FOIL both of these out, which means I'll have a cotangent squared x plus 2 cotangent x plus 1. FOIL this one out. I'll have a 2 cotangent squared x minus 2. I don't know what I just said. Plus cotangent squared x minus 2 cotangent x plus 1. And again, I'm going to leave the right side alone because I'm trying to match this up. So that is supposed to equal 2 cosecant squareds of x. So notice that this one and this one reduce. So that's going to leave me with 2 cotangent squareds of x plus 2. And I want that to equal 2 cosecant squared x. Well, if I factor out this 2, I will end up with a Pythagorean identity, which the Pythagorean identity here is cosecant squared. So this becomes 2 cosecant squared x, which equals 2 cosecant squared x. So we have proven that identity. All right, so I went ahead and wrote the next one down. I noticed that I want to take this expression and make it equal to this expression using identities. So I noticed that my subtractions match, my additions match, and I do know that 1 over tangent is the same thing as cotangent. So what I'm going to try is I'm going to try multiplying top and bottom of that left-hand expression by a 1 over tangent x. So multiply this one by a 1 over tangent x, and multiply this one by 1 over tangent x. And all that's going to do is I'm multiplying by a fancy 1. So when I distribute this to the first one, I'm going to get tangent over tangent, which we're just going to write this out a step at a time. And I get tangent over tangent. And then minus 1 over tangent x. So I distributed that 1 over tangent x to both terms in the numerator. All right, so I've taken that through the numerator. Now I need to take this one through the denominator. So here's my big old denominator. Tangent x times 1 over tangent x is tangent x over tangent x. And then I'll have plus 1 times 1 over tangent x is 1 tangent, or 1 over tangent x. So my first numerator, that's going to turn into a 1 minus 1 over tangent is going to be cotangent. And then this one turns into a 1 plus 1 over tangent is cotangent. And so I end up getting exactly what I was looking for. So let's try number 18. Number 18 says I've got cosine x over 1 minus sine x. And I've got plus cosine x over 1 plus. So I'm going to leave some room here. Plus cosine x 1 plus. And I want that to equal 2 secant x. Remembering that secant is the reciprocal of cosine. So when I'm looking at these, I'm trying to find out different ways that I can handle this stuff. So I can multiply the top and the bottom hang on, my kids won't be quiet. Okay, so I'm just going to multiply this one, top and bottom, by the conjugate, which is going to be times 1 plus sine x over 1 plus sine x. I'm going to multiply this one by the conjugate, which is 1 minus sine x over 1 minus sine x. So again, I'm going to leave the right side alone unless desperate times call for desperate measures. All right, so I'm going to leave this as just cosine times 1 plus sine x, because I really don't know what's going to reduce, what's not going to reduce, all that kind of good stuff. So what I have here is 1, and then, because I'm foiling, so 1 times 1 is 1, and then I've got a positive sine x and a negative sine x, and this is going to be 1 minus sine squared x. Okay, so at this point I'm going to leave this. I may, just to see where we're headed, I may FOIL that out in a second. Why do I keep forgetting my cosine x's? All right, and so this is going to be 1 times 1 is 1, negative sine, positive sine, and then a negative sine squared. Okay, so what my numerators are is a little bit messy still, but my numerators are both Pythagorean identities. So these will both turn into cosine squared. So I've got cosine 1 plus sine x plus cosine 1 minus sine x. And again, I just haven't decided if I want to multiply that out yet or not. And then all of that over a common denominator using Pythagorean identities of cosine squared. Okay, so this becomes cosine over cosine reduces to 1 over cosine. Okay, so I'm going to reduce this cosine. So that gives me 1 plus sine x over cosine. Because this, why do I forget my x's? Good land of Goshen. So this cosine reduces with that cosine squared to leave me with a single cosine. And then I'll have plus 1 minus sine x over cosine x. Okay, so I know that I've got common denominators, which means I can combine like terms. So I've got 1 plus sine x, 1 minus sine x, means what I have on this one is going to be, let me just write it out. I've got a 1 plus sine x plus 1 minus sine x over cosine x. Okay, so 1 and 1 is 2. So that gives me a 2. And then sine x and negative sine x reduces. So I handled this and this. You can't see. Handled that and that. And now all of that is over cosine. So I get 2 over cosine x, which rewriting using a reciprocal identity gives me 2 secant x. So we have then proved our identity. So let's look at number 19. Number 19 says tan theta. Did I flip this page? Yes, I did. All right. 19 is tan theta times the cosecant of theta minus sine theta equals cosine theta. So one of the things that might be handy to do is to write everything in terms of sines and cosines. Since I want this to be a cosine, it might be handy to work this thing through. So remember that this is tangent distributed to both of these. So my tangent is going to be sine theta over cosine theta times 1 over sine theta minus sine theta. And I'm trying to get that equal to cosecant. Well, now I can distribute. So when I distribute on this, I'm going to get a sine times 1 and a cosine times sine. So a sine theta over a sine cosine. And then minus sine squared over cosine, because that's over 1. Over cosine theta. Well, I do notice, I'm trying to decide where to go here. I do notice that this reduces to 1. So I've got a 1 over cosine theta minus, I have, ooh, look at that. I have a 1 over cosine theta minus a sine squared over cosine theta. Which means I've got a common denominator of 1 minus cosine holy cow, I just skipped a step. That gives me 1 minus sine squared theta over cosine theta by a common denominator. So from here, I'm going to take that to the Pythagorean identity, which is cosine squared theta over cosine theta. So once that reduces, this is all very crooked, and it's probably making you dizzy, which gives me a cosine theta. All right, so number 20, we have sine alpha minus beta. And that's going to be over sine alpha sine beta. And we want that to equal cotangent beta minus cotangent alpha. Oops. What? Cotangent beta, sorry. All my Greek letters are just writing themselves. Okay, so the first thing I do notice is I'm trying to get to in terms of cotangents, which means I really want this to be cosines over sines. So I'm going to go back to my sum and difference identities. So looking at your sum and difference identities, sorry, as I try and dig mine out, what you should have on your handy-dandy notebook is, it's not a handy-dandy notebook. I have, oh, where did it go? Give me a second. There it is. Sum or difference identities. If I am subtracting alpha and beta, I'm going to change that into sine alpha cosine beta minus cosine alpha sine beta. So that's what this is turning into. So I now have sine alpha cosine beta, and that's going to be minus cosine alpha sine beta. And all of that is going to be over a common denominator of sine alpha sine beta. So I've got a sine alpha sine beta. And then that's going to be my common denominator. So sine alpha sine beta. Okay, so all I didn't have to write this as a continual fraction. So I've got the first chunk over my common denominator minus the second chunk over my common denominator. And then let's see what we've got. Okay, I've got sine alpha over sine alpha is 1. Cosine beta sine beta is going to be cotangent beta minus cosine beta sine beta turns into cotangent beta. Okay, making sure all this matches. Cosine, and then I actually went backwards. Give me a second because I was rushing. Sine alpha, cosine beta, cosine beta. That was supposed to be a sine. This does not work. Okay, so sine beta over sine beta reduces to 1. And then cosine alpha over sine alpha reduces to cotangent of alpha. So 1 times the cotangent beta is a cotangent beta minus 1 times the cosine alpha, which is hard to see, times 1 is cotangent alpha. And that's what we were trying to get. So I'm so sorry. I wrote that as cosine cosine instead of cosine sine. So that's what made me hiccup right there a little bit. All right, so let's see what we got next. I would like to find the equation of the graphs. So I am not going to bother drawing these things because they're okay. So it's the 4th of July and there are 20 million fireworks going off. All right, so here's what we've got. We've got 2 different equations. I'm going to use this one first, so ignore him. What I do notice is it's going to be awfully easier if you notice. It's kind of hard to see. My little grid marks kind of sort of line up pretty right here, but they really line up pretty right here. Okay? So I can allot for a phase shift to the left that many units. And then that's going to help me find out what my answer is. So I am going to go off the fact that this thing is going to be, and I'm second guessing myself, because this is multiple choice, so I need to do this in the right, if we're doing cosine and that type of thing. It doesn't say. All right. Oh, whatever. Wait, I was looking at the wrong one. Okay, so we're going to do sine. So it says to do sine. So I need to fill in y equals a. Can you see what I'm doing? Y equals a times the sine of bx minus c plus d. So I'm asked to do this in terms of sine. So the first thing I would like to notice is what is my amplitude? Okay, my amplitude from bottom to top, I'm going to go from a top of 7 to a -1. So 7 minus -1 means my total wave height is 8. And so my amplitude is half of that, so my amplitude is 4. Okay, I also notice that if this is going to be my central part, so 7 minus 4, -1 plus 4, that means I shifted that thing to the left a little bit, and you'll notice it drops down. Normally sine would go up, okay? Like this right here, sine is going up. So that's what you would expect to see, which means I have been flipped across the x-axis. So I'm going to lead off negative. So I've got an x-axis reflection. The next thing I want to do is find out how far up or down I went. Okay, so if this thing is supposed to hit at the origin, that means I must have went up 3 units. Okay, so he was supposed to hit at the origin, but I went up 3 units. So my vertical transformation, which is D, is going to be up 3 units. So he'll be positive 3. Okay, so the slightly more difficult part is going to be us deciding what the period of the function is, and it's going to be us deciding what the phase shift is. Okay, so let's do the period of the function first. The period of the function is going to be defined by 2 pi over the absolute value of v. So I've got to figure out when this thing starts replacing itself, or starts repeating itself. So I do know that this right here is a good repeat, and I know that this right here is a good repeat. So if I can go from here to here and find off my markers and then subtract, I'll know how long it takes to get from here to here. So we have got a width, an interval of 24 pi's, because 11 pi's over 12 minus 23 pi's over 12 is 25 pi's over 12. And so when I mark this off, I find out that this is in 1, 2, 3, 4, 5, 6, 7, 8. So I took 24 and divided it by 8. So each tick mark represents a pi over 3. Okay, so I added, and I'm going to write in pencil, I added a 3 pi over 12. On this one, I added a 3 pi over 12. On this one, which is what I'm interested in, I added a 4 pi over 12. This one I added a 3 pi over 12, so he's a negative pi over 12. This one I added, so he's a 2 pi over 12. This one I added, so he's a 5 pi over 12. And then this is the next one I'm interested in, and that is going to be an 8 pi over 12. So how did I get from here to here? Because that's going to be the period. So 8 pi's over 12 minus 4 pi's over 12 is going to be, minus a negative 5. 8 pi over 12 minus a negative pi over 12 is 12 pi's over 12. So I find out that the actual period is going to be a pi. Okay, so I need to find out what my coefficient is. So I'm going to cross multiply. So I have 2 pi's equals pi b, divide both sides by pi, and I get my coefficient is going to be 2 pi. So my coefficient, b, equals 2 pi. The last thing I need to know is there a horizontal shift, which we already knew that there was. So if I have a horizontal shift, and this one gets a tiny bit tricky, where did I go? Okay, this right here is supposed to actually cut the wave in half from top to bottom. So for my amplitude to be 8, I know that 4 minus 3 is my middle part. And I do notice that he got shifted to the left pi over 12. Okay, so he got shifted to the left pi over 12. So my phase shift is left pi over 12. So when we start building this thing, what we have is our lead coefficient of 4. However, he got flipped across the x-axis, so it's a negative 4. I also declared at the outset I was dealing with sign. The next thing I know is where I need to be careful. Okay, my b value is going to be a 2 pi. That's the coefficient on x. So my b value is going to be a 2 pi. Let me make sure I just did that right. 2 pi. No, it's just going to be a 2. Sorry. I was thinking that's wrong. All right, so that is just going to be a 2. And that's going to be multiplied to my phase shift. So what did my phase shift do? He went x minus pi over 12. So that says I went left pi over 12. Finally, don't forget we went up 3. So now I can continue this, clean it up a little bit, and I got 2x minus a pi over 6 plus 3. So I'm going to go ahead and do one more of these just to get it knocked out of the way because it's a good starting point for the next set. So I have find the equation of the graph given below. Okay, so what I know first of all is from the y-axis, I'm going to go up a half and I'm going to go down a half. So that tells me immediately I'm dealing with a sine function, and it got compressed by a factor of 1/2. So normally I would have an amplitude of up 1, down 1, which would give me a total wave height of 2. On this one I've got up a half, down a half, so that gives me a total wave height of 1. So again, I want this in this format, which is bx minus, oopsie, piece of crap, minus c plus d. So the first thing I can knock out is what is my amplitude. So my amplitude, again, from the center is going to go up a half and down a half. So my amplitude is 1/2. Did it get flipped? So from the center, did it go down? Yes, it did. So I have an x-axis reflection. Okay, next thing I want to do is find out if I've got a vertical transformation. So basically we get all the easy stuff out first. Vertical transformation. Okay, so remember, this thing is supposed to hit as 0, 0, but where did we take it up to? We took it up to 2. So my vertical transformation is plus 2. So the next thing we've got to do is look at our increments. So I'm just going to go from peak to peak because that's going to be easiest. And I notice that this is -4 and that my next peak occurs at 12. So 12, there's my peak, there's my peak. 12 minus -4 is 16. So I know that the period of my function over the coefficient needs to give me 16. So the period of my function over the coefficient will give me 16. So I get 2 pi over 16 is b, which gives me a pi over 8. So my phase shift is going to be where I just found the period. What the heck? Not the phase shift. The phase shift, the period, is pi over 8. Now I need to know what the phase shift is. Sorry, got excited. All right, so my phase shift is what? Did I move left or right? No, I didn't, because that center part, I've got some symmetry. I can go up a half and I can go down a half and I can find my graph. So I do not have a horizontal phase shift. So again, looking at this, we've just got to put the whole thing together. So when I put the entire thing together, I get y equals, let's put it over here, y equals, did I write down that you flipped it? No, I did not. Yes, x-axis reflection. So a -1/2 times the sine of what's the period of my function. The period is pi over, you can't see, period is pi over 8. I did not move left or right, and then I went up 2. So there's no distribution that needs to be done in the argument of the trig function. And that's a great place to stop.